I welcome you to ICS Mahesh P. U College Dharwad to the Department of Chemistry. Dear students, in our previous class we had understood about the crystalline and amorphous solids. The classification of crystalline and amorphous solids were made based on the type of constituent particle and the arrangement of constituent particle, dear students. We have understood about the distinguishing properties of crystalline and amorphous solids. Today we are going to understand about the classification of crystalline solids. Crystalline solids are classified into four types on the basis of the nature of intermolecular forces operating in them. And the classification is molecular, ionic, metallic and covalent solids. Dear students, the classification is made based on the intermolecular forces, as I have mentioned, and intermolecular forces are dependent on the constituent particles. In your lower classes you have studied, dear students, the intermolecular forces present in molecules will be hydrogen bond, dipole-dipole, dipole-induced dipole, etc. The intermolecular forces present in ionic substances are electrostatic or Coulombic force. The intermolecular force present in metallic substances are metallic bond. The intermolecular forces present in covalent substances are covalent bond. Okay, so the intermolecular forces classifies crystalline solids into four types: molecular, ionic, metallic and covalent solids. Let us understand one by one. First one, molecular solids. These are the crystalline solids in which the molecules are the constituent particles. They are further subdivided into the following categories. Dear student, understand the constituent particles, intermolecular force and examples in this classification. First one in molecular solids called as non-polar molecular solids. These are the molecular solids in which the constituent particles are either atoms of argon and helium or the molecules like hydrogen, chlorine and iodine formed by non-polar covalent bonds. So here constituent particles are molecules, intermolecular force is non-polar covalent bond. Okay. Number two, polar molecular solids. These are the molecular solids in which constituent particles are molecules containing polar covalent bond. The molecules are held together by relatively stronger dipole-dipole interactions. Examples: solid HCl, solid sulfur dioxide and solid ammonia. Dear student, why there must be dipole-dipole interaction? Because each molecule of an example for each molecule in HCl, okay, is a dipole. So there must be dipole-dipole interactions. Okay. Number third, hydrogen bonded molecular solids. Before going to it, I would like to define again what do you mean by a hydrogen bond. An hydrogen bond is a type of bond formed by between the atoms hydrogen and electronegative atoms like fluorine, nitrogen or oxygen. Okay, this is hydrogen bond. Then what are hydrogen bonded molecular solids? These are the molecular solids in which held by hydrogen bonds between hydrogen and fluorine or nitrogen or oxygen atoms. Okay, example: ice, solid ammonia, etc. So molecular solids are classified into non-polar, polar and hydrogen bonded molecular solids. Let us understand the other solids. Ionic solids, dear students. Ionic solids are the type of solids in which the constituent particles are ions like cations and anions, which are held by strong Coulombic or electrostatic forces. Example: sodium chloride, zinc sulfide, magnesium oxide, etc. Okay, so dear students, try to understand. Ionic solids are made up of ions like cations and anions, and therefore the intermolecular forces must be Coulombic or electrostatic forces. I'll take an example of sodium chloride. This is an ionic solid. Constituent particles are ions. What are the ions present in sodium chloride? You know that sodium chloride contains sodium ion and chloride ion, dear students. Okay, so and hence these ions must be held by Coulombic or electrostatic forces. Okay, next is metallic solids. These are the crystalline solids, understand dear students, made up of atoms of metals. Dear students, special mentioning is here metal kernels and sea of mobile electrons. Metal kernels and sea of mobile electrons, dear students. Try to understand this one, dear students. Let me define it again. The constituents are positively charged metal kernels. Metal kernels are the atoms, okay, which have lost electrons in the respective metal. A given atom in a metal loses electrons, then the remaining part of an atom is called metal kernel, and there are n number of these metal kernels in the metal, and therefore there are n number of free mobile electrons. So therefore, if you consider there is a metal, it must be formed with metal kernels and free mobile electrons. Okay, and what is the intermolecular force? It is the metallic bond, dear student. Example: zinc metal is made up of zinc metal kernel and present in the sea of mobile electron. Just look at this particular example, dear student. You imagine this is a zinc metal, you imagine this is a zinc metal, or you just imagine this is a sodium metal. Sodium metal contains sodium atoms, isn't it? So sodium atom, if it loses one electron, it becomes sodium ion. You can call that sodium ion as metal kernel. So there are n number of sodium ions are there. So therefore you can imagine there are n number of free mobile electrons. There are n number of electrons are there. It is like sodium ions are dispersed or dipped in the sea of mobile electrons. It's very simple, dear student. Metallic solid consists kernel, that is metal ion, and it is present inside the sea of mobile electron. Intermolecular forces, what is the intermolecular force? Intermolecular force is metallic bond. Fine. So metallic solids. Fourth one, that is covalent or atomic or metallic or network solids, dear students. It is called covalent or atomic or network solids. So dear student, you have come across substances like diamond, graphite, and fullerene. These are the examples of covalent solids. What are these must be made up of? Let us understand. These are the type of solids in which the constituent particles are covalently bonded non-metallic atoms like carbon, silicon, etc. And what is the intermolecular force? It must be the it must be covalent bond. It must be the covalent bond. Example is diamond, graphite, etc. Okay, so this is the covalent or atomic or network solids, dear students. Okay, dear students, one or two more points I would like to add about diamond, graphite, and fullerene. In the case of diamond, it is made up of carbon atoms held by covalent bond, and each carbon atom is sp3 hybridized. Each carbon atom is sp3 hybridized. Okay, and diamond, dear student, it is non-conductor. Why it is a non-conductor? Because there is no free available electrons in the crystal. So therefore diamond is a it is an insulator, it do not conduct. Then why diamond? And another point in diamond is a hard substance. Why diamond is a hard substance? Because of its structure due to sp3 hybridization, dear student. Okay, next comes graphite, dear student. Graphite is also made up of carbon, and carbon is sp2 hybridized, and each carbon atom in graphite provides single electron which is present in unhybridized p orbital. Therefore graphite, dear student, it conducts electricity. Graphite conducts electricity, whereas diamond do not. And graphite, another distinguishing properties, dear student, it is soft. Unlike diamond, it is soft. Why it is soft? Because graphite is made up of layered structure, and each layer it is held by weak van der Waals forces of attraction. Okay, so next, the third type of example is the Buckminster fullerene. Okay, these are made up of carbon 60 atoms, C60 atoms. So hybridization comes, it is sp2, and it is also the non-conductor, and it is also the not bad conductor of electricity, the Buckminster fullerene, dear students. Fine, let us further investigate about these types of crystalline solids, dear students. Let us understand. There is a chart here which consists type of solid, constituent particles, attractive forces, examples, physical nature, electrical conductivity, and melting point. So if they ask for descriptive, you can explain it with this particular chart, dear student. So number one, molecular solids, as you have studied, it is made up of non-polar molecular solids. It is of different types like non-polar, polar, and hydrogen bonded. So constituent particles, which one? It is molecules. For all it is molecules. For non-polar only it is atoms, that is of noble gas. What is attractive force? In the case of non-polar, it is the dispersion or London force, or it is also called as non-polar covalent bond. It is called as non-polar covalent bond, dispersion, or London force. Examples: CCl4, H2, I2, CO2. Okay, what is the physical nature? It is soft. Why it is soft? Because the intermolecular forces are weak. It is soft. Electrical conductivity, it is a bad conductor of electricity. What is melting point? Melting point is very low. Melting point is very low. Okay, number two, it is the polar. Constituent particles are molecules. Attractive forces are dipole dipole interactive force, dipole dipole interactive force, and example, it is HCl, SO2, etc. Physical nature is soft. Electrical conductivity is an insulator. Melting point is low. Okay, same. Generally non-polar, polar, and hydrogen all are having similar properties. You remember the attractive force, you remember the example, and physical nature is almost similar. Electrical conductivity is also same. Melting point is also almost same. Hydrogen bonded attractive force is hydrogen bond. Constituent particles, as you know, hydrogen, and non-metallic atoms like fluorine, oxygen, and nitrogen. Example, H2O, that is ice. Physical nature is hard. Electrical conductivity is insulator. Melting point is low. Okay, let us go for the next one. Okay, so ionic solids, constituent particles are ions. Attractive forces, the electrostatic forces. Example, NaCl, magnesium oxide, zinc sulfide, calcium fluoride. Physical nature, it is hard but brittle. Electrical conductivity, it is an insulator in solid state but conduct in molten and aqueous solution state. Melting point is high. Dear student, try to understand. Ionic solids made up of ions. Electrostatic force, example, they are hard because you have to understand the type of force is electrostatic force, strong force, therefore the substance is hard. It is insulator. It is insulator in solid state, because in the case of solid state it is held by electrostatic force. Okay, but conduct in molten and aqueous state. But conduct in molten and aqueous state. In the case of molten or aqueous state, the bond is broken. Okay, there is mobile ions available, and it is the electrical charge carrier, so therefore it conducts in the molten or aqueous solution state. Melting point is high. Okay. Third is metallic solids. Constituent particles, positive ions, they are called as kernels in a sea of mobile electrons. Attractive forces, metallic bonding. Example, iron, copper, silver. Physical nature, they are hard. Why they must be hard? Because metallic bond. But malleable and ductile. Malleable and ductile, they can be made into thin sheets, they can be stretched into long wires. Okay, because this can be explained based on the explanation that when you apply force on a part of a metal, okay, a layer of atom slides over the another layer. Okay, therefore it can be made into thin sheets and stretched into long wires. Electrical conductivity, you know, dear students, you can see there is large number of electrons are there, therefore it conducts in solid and as well as molten state. Melting point must be high. Melting point will be high when attractive forces are stronger. Covalent or network solids. Covalent or network solids. Okay, constituent particles of covalent or network solids are atoms, non-metallic atoms. Attractive forces, covalent bonding. This will be like a revision, dear student. Okay, SiO2, that is called as quartz, silicon carbide, diamond, aluminium nitride. Physical nature is hard. It's hard. Electrical conductivity is an insulator. Melting point is very high. Okay, so these are